All right, so this is section 5.5. We're going to talk about indirect proof. And let's put the electronics away, please. So when we're doing indirect proof, we're going to use what we call indirect reasoning. So let's talk about what we mean by indirect reasoning. And then we'll contrast that with the way we've been doing proofs so far. So with indirect reasoning, what we do is we kind of work backwards. We prove possibilities false until we're only left with one possibility that can be true. So with indirect reasoning, we prove our different possibilities false until we're only left with one possibility remaining. So we eliminate different possibilities until we get to the only thing that can be true. So we call it indirect because we're proving things false rather than proving things true. Now to contrast that with direct reasoning, which is what we've been doing mostly so far in geometry, in direct reasoning, we start with something that we know is true, and then we link true things one after the next. So we say, if this is true, this has to be true. This has to be, if this is true, then the next thing has to be true. So we're linking true things together to get to what we're looking for. So direct reasoning, we link true things together. So we call that direct reasoning. And the other is indirect reasoning because we're proving things false. We're kind of going backwards. What we're going to do with indirect reasoning is what we call an indirect proof. To do an indirect proof, the other name that you'll see, let me put it in parentheses here, or is a proof by contradiction. We do a proof by contradiction. So what we do is we start by assuming temporarily the opposite of what we're trying to prove. We're going to assume the opposite of what we want to prove. And then we show that that leads to a contradiction. Now, what do we mean by a contradiction? What's a contradiction? Something that doesn't make sense put together. It's impossible for them to happen together. So a contradiction is something that is impossible, essentially. So a contradiction means something that's impossible based on what we know. So in parentheses, I'm going to say something impossible. Well, if what we assumed leads to something impossible, then the original has to be true. So we assume the opposite. That opposite thing leads to a contradiction, something that's impossible. So the opposite thing can't be right. So the original has to be true. I'm going to say the original, we could say statement, original thing. I'm just going to say means the original has to be true. So we assume something is true. We show that that leads to something impossible. So whatever we assumed can't be right. So the original thing that we were trying to prove has to be true. So it's kind of like saying, well, I didn't go to the store. Well, let's assume that I went to the store. Well, if I went to the store, then I would have had to leave the house. But I didn't leave the house. It's impossible. So I didn't go to the store. It's kind of going backwards. Show that we get to something that's impossible. So that means that the thing that we said originally isn't right. So the very, very beginning thing that we started with has to be true. So our steps, when we do an indirect proof, we have 3 steps that we do for an indirect proof. We start by assuming, and we're going to say temporarily. So we're not assuming it permanently, temporarily. So we assume the opposite of what we want to prove. Then we show that that leads to a contradiction. And contradiction, we mean something that's impossible. That tells us that the thing that we're trying to prove has to be true. If the opposite leads to a contradiction, the thing that we're trying to prove has to be true. So I'm going to say our temporary assumption is wrong. So what we're trying to prove has to be true. So these are our steps for doing a proof by contradiction or an indirect proof. Assume the opposite of what we're trying to prove. Show that that leads us to something that's impossible. That means that our assumption has to be wrong, so the original thing we're trying to prove has to be true. So what I want to do is we'll practice on a couple of things. Just pick how do we pick the opposite, or how do we assume the opposite of what we're trying to prove, and then we'll talk about finding contradictions, and then we'll do a really easy indirect proof. One way that you might be familiar with, they use indirect reasoning, is when you do a Sudoku puzzle. So you look at the rows and the columns, and you say, well, what happens if I put a 3 in this square? And then you think, well, if I put a 3 in that square, then I would have to put a 2 in this square, but that's impossible, so I can't put a 3 in the square. So you try out the possibilities and show that the possibilities are false to get to the answer that you want. So Sudoku is an example of indirect reasoning. So let's take a look at let's pick our first steps for a couple of statements. So we want our first step in an indirect proof. So the first one, we're going to say given, and we can say a number, but I'm going to say make it a little more specific. An integer n. So an integer is a kind of number. Do we remember what kind of number an integer is?
No fractions.
No fractions. Okay, that part's right.
It's a non-fractional number, either in the negative or positive.
It can be negative or positive. So anything that's not a fraction. So 1, 2, 3, 4, 5, 6, negative 1, negative 2, negative 3, negative 4, negative 5, 6, negative 6, etc. So we're given this number. We want to prove n is divisible by 2. So we're not going to go through the proof for these first two examples. We just want to figure out what would be our first step in an indirect proof. So if we want to prove that n is divisible by 2, what would we assume? We would say we want to assume the opposite. So what did you say then? Right, so our first step, assume n is not divisible by 2. That would be our first step if we were going to do an indirect proof here. We would assume the opposite of what we're trying to prove. So that would be our first step. So that's all we wanted to do for this one was figure out our first step. This one, let's say we have a bunch of people, and we want to prove in a group of people that there are at least 16 right-handed people. So this one we need just a little more work. So we want to prove that there are at least 16 right-handed people. What is another way of saying, or what's a mathematical way of saying at least?
Equal to or greater.
It has to be greater than or equal to. So at least means 16 or more is another way we could say it. So greater than or equal to. So let me write it in words. I'm going to say 16 or more. So we want to prove that there are 16 or more right-handed people in this group. So our first step in an indirect proof would be what? Okay, so there are not 16 or more, and how could we say that? Just be a little more precise with that. There are less than 16. We're going to assume there are less than 16. So we want to prove that there are 16 or more. The opposite of that is saying there are less than 16. We're going to assume that there are less than 16. So that would be our first step of an indirect proof of this thing. Whatever other information we have, we don't have it right now. All we want to do is pick out our first step. So our first step in an indirect proof is assuming the opposite of what we're trying to prove. So sometimes it's really easy. Sometimes we can just put a not in front there. Other times we have to do just a little more work to figure out what the opposite actually is. Questions there? Okay. Let's practice. Now I want to just practice finding a contradiction. So in these examples, we're going to list 3 things, and we want to pick the 2 that are a contradiction. So first thing here is I'm going to say a triangle is acute. So what do we mean when we're talking about an acute triangle? What's an acute triangle?
No angle.
All the angles are less than 90 degrees. Second one, a triangle is scalene. Do you remember what scalene means?
No equal angle.
None of the angles, none of them are the same. None are equal. Very nice. And then the third one is triangle is obtuse. So which of these two give us a contradiction? So everybody think about it for a minute. So which of these two are impossible to happen together? 1 and 3. A triangle can't be acute and obtuse at the same time. It could be acute and scalene. It could have all different angles. That's fine. And it could be obtuse and scalene. That's fine. It could have an angle larger than 90 degrees, but all the angles could be different. But it can't be acute and obtuse at the same time. 1 and 3, because a triangle can't be acute and obtuse. All right, so let's look at another one, another set here. L is parallel to M. These are lines. L and M are skew, and 3, L and M don't intersect. So which of these two are contradictions? Which of these two cannot be true at the same time? So let's remember what we mean by, first off, L is parallel to M, and we're saying for number 3, L and M don't intersect. What does don't intersect mean? They're parallel. So let's think, what does skew mean? What does skew line mean? So they don't intersect, right? You're doing this with your arms. They don't intersect, but they are not parallel. So my example for skew lines I always say is the C-wing hallway and the main hallway downstairs. They don't intersect, but they're not parallel. So two lines cannot be parallel and skew. So 1 and 3 have to be contradictions. Sorry, 1 and 2. 1 and 2. So I'm going to say lines can be parallel and skew. Because skew lines are not parallel. Lines cannot intersect and be skew. They can intersect if they're skew. And lines don't intersect if they're parallel. So those aren't contradictions. All right, let's look at one more set of 3. This one's a little trickier. So I'm going to say for this one, triangle ABC is a right triangle. So number one, so all of these talk about angle ABC, the triangle ABC. Angle A, measure of angle A is 60 degrees. 2, measure of angle A equals the measure of angle C. And 3, measure of angle B is 90 degrees. And we want to know which of these two are contradictions. Which of these two cannot happen at the same time. So hang on for just a second, let everybody think about it for a minute. So the first one says the measure of angle A is 60 degrees. Third one says the measure of angle B is 90 degrees. And the second one says the measure of angle A and measure of angle C are both 60. And we know that this is a right triangle. So let me draw a picture. Not necessarily to scale, but I just want to label my triangle. This says measure angle B is 90. I'll call this A and this C. So there's a picture to help us visualize. So which two can't happen at the same time? 1 and 2? And why can't they happen at the same time? Okay, very nice. So what Ben says is that if A and C are equal, and A is 60 degrees, then angle C is 60 degrees also. 60 degrees plus 60 degrees is 120. And if it's a right triangle, the other angle is 90. 120 plus 90 is 210. So they add up to more than 180. Angle A and C, let's look at 2 and 3 together to see why those two can happen at the same time. The measure of angle B is 90, and A and C are the same. What would angle A and angle C have to be? What was it? Someone said it. These two angles are the same, and they have to add up to what for my inside my triangle to be 180? If this is 90, what do these two have to be together? They have to be 90 together, and if they're equal, what is each one? 45. So 2 and 3 would describe a 45, 45, 90 triangle. So those two can happen together. And number 1 and 3, if angle B is 60 and angle A is 60 and angle B is 90, what's that leave for angle C? 30. So that could be a 30, 60, 90 triangle. So 1 and 2 are impossible because our angles, I'm going to say all angles add to 210 degrees, which we know isn't true inside a triangle. So those two would be impossible to happen at the same time. Questions on that one? Okay, so that's the second step. The second part of doing an indirect proof is finding a contradiction. First step, assume the opposite. Second step, find our contradiction. So the last thing I want to do is do a really easy indirect proof. So let's take a look at that. So we're going to be given that 5 times x plus y equals 50, and x does not equal 3. We want to prove y doesn't equal 7. So we're given that this equation is true and we know that x doesn't equal 3. We want to prove that y doesn't equal 7. So what's our first step here? For an indirect proof. We want to assume the opposite of what we're trying to prove. So how do we assume the opposite of what we're trying to prove? Assume, what are we going to assume? That y does equal 7. Assume y equals 7. So we're going to assume temporarily that y equals 7. All right. And then we are going to show that this leads us to a contradiction. So let's plug in y equals 7 into our equation. I'm going to say, so 5 times x plus 7 equals 50. So I'm assuming y equals 7, so I'm going to plug that into my equation. Now I'm going to distribute. So 5x plus 35 equals 50. Subtract 35 from both sides. I get 5x equals 15. Divide by 5. And x equals 3. Do we have a contradiction? Yes. We're given that x doesn't equal 3. So we'd say, but x is not equal 3. So our assumption is wrong. So what we were trying to prove has to be true. So y cannot equal 7. If y equals 7, then x equals 3. But we were told that x does not equal 3. So y equals 7 can't be true, so y can't equal 7. So that's our indirect proof. We assume the opposite of what we wanted to prove, show that that leads to a contradiction. So that means what we were trying to prove has to be true. Questions there? Proof by contradiction or indirect proof. When we can do an indirect proof, it's kind of nice because when you can find sometimes it's easier to find a contradiction than to figure out how things are related to each other one after the next. The way we've been doing proofs. It's a
little less formal.
A little less formal, yes. Because to do a direct proof, you have to link the exact right thing one after the next. Here we just have to do something that shows that we get a contradiction. Here we just solved the equation. And that gave us our contradiction. Back here, our contradiction was if these two angles are equal, then all of our angles in our triangle add up to more than 180. So that's not too hard of a contradiction to find. All right. So there's our indirect proof. Questions? Okay, let me do this. Let me write down the homework because we're going to do several other things before we get back to this. So we're on page 319. Through 14 even and 18 through 28. All right.